Welcome to The Explainer. Today, we're diving into something pretty wild from the world of academia. A paper that imagines a future where our cities don't just sit there, but actually listen and respond to us. So the paper kicks off with this really powerful quote from the author. It points out that even in our smart cities, the actual stuff they're made of, the walls, the sidewalks, they're just silent. They're basically just a passive backdrop to everything we do, not a part of the action. And that right there leads to the big question driving this whole thing. What if the physical fabric of our cities could actually tune into us? What if it could react to the music and the vibe of a community and do it in real time? All right, so here's the game plan. First, we're going to talk about why our cities feel so, well, lifeless. Then we'll get into the crazy toolkit the researchers propose, a mashup of music, quantum physics, and city planning. After that, we'll look at the actual tech they've designed, how they plan to prove it's the real deal, and finally, we'll ask what this all means. Is this the future of the smart city? Okay, so let's really dig into this first point. What's the actual problem they're trying to fix here? Why do our cities feel so disconnected, even with all our tech? I mean, think about it. We've got smart traffic lights, we've got sensors everywhere, but the actual buildings, the concrete, the glass, they're just dumb structures. They can't tune into what the paper calls the cultural sound fields of human life. You know, the music, the chatter, the whole energy that makes a place feel alive and unique. So how in the world do you even begin to tackle a problem like that? Well, this is where things get really, really cool. The researchers mashed together three fields you'd never ever expect to see in the same room. I mean, get this. They're mixing the study of music with the mind-bending physics of tiny particles, and, of all things, the rules of city zoning. It's a completely radical approach, pulling from all these different worlds to create something totally new. Yeah, the paper has a fancy name for this, structural overlay logic. But really, you can just think of it like this. They're taking the core ideas, the best bits, from each of these completely different worlds and layering them together to invent something that just couldn't exist otherwise. And here's how that crazy combo actually plays out. First, you use music theory to teach a wall how to listen, how to understand the patterns in the sounds around it. Then, you bring in quantum physics to give it a body, to let it act by physically changing its surface. And finally, you use urban planning to give it a rule book, to make sure it obeys local laws like noise limits. Okay, so this is all great in theory, right? But how do you actually build something like this? Well, this isn't just a thought experiment. They've actually designed the hardware. Say hello to the QR metatile. Picture a tile, maybe about 50 by 50 centimeters, that you could use to cover an entire building. Each one of these tiles is basically an ear and a mouth all rolled into one. It hears the sounds, figures out what they mean, and then instantly changes how it bounces back sound and light. So here's the magic behind it, this four-step dance. The tiles are always listening for patterns. And then, and this is the absolute key, the quantum part, they use what's called entangled photons to sync up. That's where two particles are linked, so what happens to one instantly affects the other, no matter how far apart they are. It's wild. It means the whole wall can make a decision instantly, all at once. Then tiny actuators physically change the tile's surface, all while making sure it doesn't break any city rules. And you know what that quantum link gets you? Speed, like serious speed. The entire wall can react in under 250 milliseconds. To put that in perspective, existing smart tech takes about twice as long, clocking in around 500 milliseconds. It's the difference between a clunky, laggy response and something that feels truly alive. Okay, but let's be real. A claim like, we're using quantum entanglement in a wall, is pretty out there. How do you prove it's not just a really, really fast computer pulling the strings? Well, the paper has an answer for that. A clear test to prove this is the real deal. They're going to use a famous test from quantum physics called the CHSH inequality. Now, stick with me here. Imagine a game where the rules are set up so that if you're playing normally, with classical physics, you just can't win all the time. A regular computer will always hit a hard limit. But a quantum system, it can use the weirdness of entanglement to kind of cheat. And that's how you prove the link is genuinely quantum. So in this game, the highest score you can get with a normal system is a 2. Anything above that is impossible, unless you're quantum. And this paper predicts their system will hit a 2.4. Bam! Proof. The quantum handshake between the tiles is real. All right, so let's fast forward. Let's say it works. The test is a success. We can build these things. What does that world actually look like?
This is where the researchers get very real about the two sides of this coin, the incredible promise and the very serious peril. First, the good stuff. The upside here is massive. We're talking about spaces that are just more pleasant to be in. They could dampen annoying city noise. They could save a ton of energy, over 15% by adjusting to the sun. But the biggest one, they could actually make people feel more connected to their community, like their surroundings finally get them. But, and this is a big but, getting there is not going to be easy. There are huge hurdles. First, just making these things at scale would be incredibly complex and expensive. Then there's the physics itself. Quantum entanglement is super delicate. And maybe most importantly, you've got these massive societal questions, like who gets to decide which culture the wall listens to? And this right here really lays out that double-edged sword. For every amazing promise, there's a pretty scary potential downside. That dream of a space that responds to culture, it could turn into algorithmic stereotyping. A more connected community, that might mean constant surveillance. And creating a harmonious vibe for one group could mean shutting out another. And so, in the end, this whole paper isn't just about the tech. It leaves us with a much bigger, much more human question. If we could actually make our cities listen, what should we be telling them to hear? What parts of our culture get amplified, and who gets to decide? It's a question not just for scientists and engineers, but for all of us who have to live in these spaces.